Good afternoon, everyone. Welcome to our live webinar. I'm so glad that you've joined us in this webinar titled Cloud Security and Compliance with AI, how to protect patient and user data in Medtech and Mediatech. My name is Jacek. I'm co-founder of Neoncube, and I'll be your host today. At Neoncube, we specialize in delivering Medtech and Mediatech applications. We've worked with various product owners and managers for many years, and lately, in the last 5 years, we've seen great significance of the security aspects and data privacy in the systems that we are building. And we want to delve into these topics, and with me is our guest, Michał Smoliński, who will be helping us unravel all the aspects of all these things. Hello, Michał. Good to have you here. Okay, so let's start maybe with some technical background. We'll have a short Q&A session at the very end. We'll try to answer as many questions as possible. In case we miss something, feel free to reach us out or leave your contact information, and we'll be happy to help. So maybe let's start with the first question for a small warm-up, let's say. So right now in Medtech and Mediatech, what do you think is the current landscape of the data security and user privacy and compliance? What do you understand by these topics? What do they mean to you?
Hi, Jacek. Hello, everyone. Great to be here. That's a very good question, a very broad one, because today the world is changing very fast. We used to work in a so-called dynamic environment. However, what we see recently is a significant speed up of things. This relates also to compliance challenges the compliance tries to adjust to the immense speed of innovation, new technologies that change the so-called paradigm. They change the fundamentals of how we build systems, how we interact with systems. So yes, that's definitely a challenge. Some say that's a chaos. Actually, we try to tame it. But I think that the best thing is to always return to the very basic and fundamental principles of good engineering, good practice. Don't get distracted by the hype. We always try to. This is something that we always been doing, and I think it's still valid for the years to come. It's always good to understand the fundamentals of any technology, and just don't rely on the hype. And this also has an application to the post-AI world, I think, because what we see right now is a lot of misconceptions. There's a lot of people talking really about super complicated things that they don't know how they are built, how they work, and how to take most advantage of these new technology without being overwhelmed.
It's quite a paradox, would you say, these times, because the world is speeding. We have access to so many new tools. The AI hype is there. We have access to so many new technologies, cloud-wise, infrastructure-wise. But paradoxically, because of this many informations, there is also a disinformation, and we still need to adapt and learn to the new things. Because the world is, in my opinion, people like to be lazy. They don't like to change their perspective that often. So they like when the things are constant. And so it's pretty difficult to maintain sanity here. So in order, you on one hand have to still work with new technologies, be competent as a businessman, but on the other hand, stay sane and don't, like you mentioned, don't waste yourself in all of this hype.
I think in terms of, for me personally, maybe it's surprising, but I would say that we've been there already. I mean, in some sense, we've seen this time of paradigm shift about 15 years ago when we started Neoncube and we started our first operation in Krakow. We've seen that there was a surge of cloud projects. The people actually realized what cloud can give them. It sped up innovation immensely. It created a new kind of software engineer that was competent in cloud technology. Something that was impossible 10 years earlier became a commonplace. And we've seen that. And there was similar hype. Maybe it wasn't seen, maybe it wasn't visible so much to the general public because it remained within the engineering circles. But we've been there already. You remember how crazy time it was.
That's true. Truly a startup world.
Truly a startup world when we really were adopting the cloud technology to build marvelous things super fast, way faster at the time, way faster than was traditionally possible. And to stay sane in that period, we also applied some fundamentals. We, for example, by building scalable systems in the cloud, which suddenly became possible without millions of investment. We were able to deliver really cheaply super scalable systems. But it turned out that we've built on technical principles developed in the 1960s and 1970s, used by such boring branches like banking or finance. Because we didn't invent that. It was there in 1960s, 1970s. It wasn't just popular. It was deemed like pretty boring. And now it's actually the same. When I was in university, the statistics most boring subjects. Suddenly, and nobody really spent much time learning it. There were more exciting things to do, like software engineering, like operating systems, databases, you name it, but not statistics. Fast forward to today, and we see that the most important skill is statistics, which is the fundamental for data science, for AI, for Gen AI, all these beautiful things. So, to be honest, for me, this is just another revolution that
Another iteration.
The reiteration of the concept. Of course, the social impact of it, in my opinion, is way more profound. We see it, but internally, I think that it's another era where we just need to readjust and relearn stuff that we didn't need so much 10 years back.
Michał, you are also a CTO of Radpoint, so a Medtech company, teleradiology pioneer based in Poland. And you, on a daily basis, work with different machine learning models, AI integrations. But we'll talk about that in a moment. For now, I wanted to talk a little bit about security and compliance. So, how do you deal with security, knowing that your application user is not only a user, but also a patient? So, to me, there is nothing more private, more intimate than my medical data. Or is this a challenge, or how do you cope with that?
First of all, I think that it's worth to unpack this concept because security is a very broad term. And different people understand it differently, and they mean different things by the word security. In our context, security is part of it is just cybersecurity, which we understand as our ability to protect ourselves from bad actors, from people who want to do harm, who want to steal data, who want to make the data unavailable, and so on and so forth. So this is one part of security. The other part of security, which doesn't seem obvious unless you are ISO 27K certified, is the business continuity. This is also part of security because, for example, in the case of Radpoint, we support emergency departments at hundreds of hospitals in Poland, providing teleradiology services, which means that our systems need to operate 24/7 with no exceptions. Otherwise, the emergency department is unable to work and admit patients. So that's why business continuity is also part of the security landscape. And there's also security in terms of what happens to the data that we have, how we as a company and our partners, how we process that. This is more related to the ethics, I would say, rather than to technology, but it's still there, and we still need to remember that. So, getting back to the first notion, the cybersecurity, is it you can't be compliant if you are not secure in the sense that you are not protected from cybersecurity threats. You just need to do it. This stems from GDPR. This stems from medical device regulation, from SOC 2, NIS 2, and all these regulations that we are now implementing or already implemented. You just need to remember that cybersecurity is the very, very fundamental to achieve compliance with almost anything. So that's the one part. The second part is that compliance also means that there are some business rules or requirements or restrictions that are in place in different branches. Like there's something that is required when you process payment data, media user data, or patient data, and putting this to the cloud actually, in my opinion, improves the security and cybersecurity of this data, because at the very beginning, when you design systems using cloud, public cloud providers, you get the architecture and components and ways to put them together that is secure by design. So actually, even if you are not an expert in a cybersecurity domain, by putting things in the cloud, you are more likely to get a system that is secure by design. And then there's also something called shared responsibility model. This is a foundational document that every cloud provider has that determines exactly who is responsible for what when you design and engineer a cloud system. So this is something that you get when you start your journey with the cloud. So it's always worth to read it, because you suddenly realize how much work in the background is done by the cloud engineers that work for you in the background we don't have to manage them. They are just for us and do their job silently, which is great, because sometimes it's difficult to estimate the costs of doing it. And here the costs are shared, because they're spread among hundreds or thousands of cloud customers, which is great, because we have then access to the best pool of talent for this.
That's true. You mentioned cost. Wouldn't you agree that for some businesses, and you mentioned cost and talent actually,
Mm-hmm.
Wouldn't you agree that for some businesses, these two factors are also a security? So a sort of a business security, I would say. It's not cyber security, but you need talent in order to prolong your business, to build your business,
And to maintain it.
and maintain it. What do you
Absolutely.
mean?
That's the second leg of security concept, the business continuity. We live in a very competitive world, and we see this every day when we struggle for talent. We try to attract the best talent. We do it at Neoncube, we do it at Radpoint, and I think that every technical leader struggles and faces the same issues, that attracting and retaining the best technical talent is not that easy these days. Especially that the roles of people in the modern engineering organizations evolve, and our needs also evolve, and they usually evolve faster than our ability to acquire the best talent. So that's why having indirect access to that pool of talent that is working for a cloud vendor is priceless sometimes.
That's true. Coming back to the data security, I imagine that at Radpoint you process huge amounts of data. It's petabytes, terabytes, you name it. A very, very big number. Let's agree on that.
Yeah.
So how do you cope with backups there? Because you, as we mentioned, deal with patient data, so something very, very fragile, very vital. And that needs to, at one point needs to be available like that on the spot to other services, other integrations. And on the other hand, given the sheer volume, there is this data security in terms of maintenance. How do you cope with that? Does cloud help you with that?
Oh yes, it does. I would put it in a different words even. I can't imagine doing it without cloud, because the cost of and complexity of achieving compliance and security of data at this scale would be immense. What I mean by compliance of this data, the medical regulations in Poland, but the same applies to almost everywhere in the world. Medical regulations require that we keep the data for, in Poland, 20 years. And we need to, just for compliance reasons, we just need to store, archive, and made available on request the data for 20 years. Many, in Poland, for example, this is what our customers tell us, many institutions like hospitals struggle with that because they usually use LTO tapes for backing up data, which is a standard technology. However, that long period of data retention usually means that the oldest data is stored on unsupported tapes that use LTO1 or LTO2 format. And this is a challenge because nobody has got resources to constantly reread and rewrite these backups or these data to newer tape formats. It's pretty complicated operation, and most of our customers is unable, for this or that reason, is unable to do it. So yes, it is a challenge. Cloud solves that because from our perspective, storing 1 gigabyte is as difficult as storing 1 petabyte. It doesn't matter, to be honest. Cloud also offers us very interesting mechanisms. So first of all, the data gets replicated to at least 3 geographical locations, but in every geographical location, the data is also replicated and is stored in several copies, which gives us an amazing data persistency. So we can achieve like 99.9999999% of probability that the data will be there when we need to read it again. So the data durability guarantees are just excellent, and I can't imagine obtaining that manually. It's basically not possible. The second thing is that we also have mechanisms that help us automatically replicate the data to a totally different geography, to a totally different geographical region, which is also great because it prevents human errors. But even on technical level, the data is durable and it's stored. However, there's still a slight chance that human error might cause the data to get deleted, get wiped out. And we can prevent that by replicating the data to another physical region, to another physical cloud vendor account, and then apply some ORM, so write once, read many policy that physically prevents the data from being overwritten or deleted. So yes, there are mechanisms that are easy to monitor, that easy to implement, and that are super robust and allow us to both achieve operational data durability as well as compliance long term at affordable prices, because there are also, every cloud provider has got different storage tiering, different pricing, depending on how you want to access the data. And generally speaking, if you only want to store the data and you don't require immediate access, then the storage is pretty cheap.
That's true. Are you using any other different AWS services, for instance, like AWS Shield, AWS?
Oh, that's also an interesting topic, because still in the context of security, now you switch to the network security.
Yeah.
That's also an interesting concept. Many people actually put an equal sign between security and network security. This is an important part of security, but it's not everything. However, the great thing about public cloud vendors is that because of the sheer size of the infrastructure, they see certain classes of attacks coming and can prevent them right at the infrastructure level. This applies to distributed denial of service type of attacks, like, I don't know, SYN attack or SYN flooding or amplification attacks. So these kinds of high traffic attacks, attempts to overcome or overwhelm systems. And if we were to implement protections to that kind of attacks by us internally, that will be possible. Basically, it will be possible. Working with large-scale cloud vendor that offers enough infrastructure to just accept the traffic and filter it out and separate the legitimate traffic from the attacks is dispensable. It actually guarantees high uptime. We've seen hundreds of cybersecurity attacks from so-called advanced persistent threats. Go figure who it is. And all of these attacks were basically we were protected, and we didn't have any operational issues, despite being under heavy attacks, which were like hundreds of gigabits per second. We just didn't notice, and this is great. And there are services that cloud vendors have for this, like as mentioned, AWS.
From my experience, I noticed that sometimes even the cloud provider likes to brag that they prevented something, and they just let you know that, hey, were you aware that?
Yes, we got a couple informal messages regarding. I don't know if you noticed that that we prevented, but we know it from the internal communications, internal talks, and this is possible also. There are two reasons why this is possible. That kind of protection is possible. First, the sheer scale of the infrastructure and ability to redirect that rogue traffic somewhere else. Where it doesn't harm anybody. You need to have an access to the fiber network of large scale to do this. And the second thing is that enter AI to the stage. AI is employed at that level, and AI is great at finding patterns in data. So it's way easier for the cloud operator to prevent these attacks from happening or to detect at the onset, because the AI provides the great monitoring and prediction and sees patterns, and that's how cloud vendor can basically prevent certain class of attacks before they actually become a problem.
Okay, so you use artificial intelligence to monitor, to filter out, but do you think will it be possible, or maybe it is, to predict predict an incident or a set of circumstances that may lead to the mentioned incident before it happens, or as quickly as it happens? Is it something that we'll be able to achieve one day?
It depends. My view on this is that usually problems in engineering systems, it doesn't apply to cloud systems. In engineering in general, usually there are usually some symptoms that we try to detect as early as possible, whether it's electrical grid systems or is it water pipes or software systems. They have their own internal dynamics, which usually has some well-known patterns. For example, our systems usually have peaks during work days from 8 a.m. to 4 p.m. We see a typical bell-shaped curve of traffic coming to our systems. Weekends are usually low traffic and so on. So we see there are some natural patterns, and AI is great at predicting patterns. So if something changes and we see that, and we already have certain tools that help us, for example, scale infrastructure up and down in predicting the likelihood of increased load over the period of next couple of hours, for example. So we already are doing it. How far we will be able to go in terms of predicting certain problems? I don't know that we will ever predict the attackers because this is just their decision to attack. However, systems have some capacity, and usually systems can accept and distribute some extra traffic without without engineer intervention. We all design systems that are capable of accepting and dealing with the increased traffic to some extent. So yes, when things start to happen, usually there is some ramp-up period, and we see that something is probably going on. Usually we have enough lead time to react or try to react. The more AI we apply to it, then probably our prediction will be better. So yes, and to some extent, probably we'll see that something is changing to the typical curve of the, I don't know, the load or number of requests served, something like that.
Okay, I wanted to move back to the compliance. You've mentioned GDPR, you've mentioned MDR, so something that you deal with at daily basis at Radpoint. But at Neoncube, we are also building media systems that have to be compliant in terms of lots of regulations, like gambling regulations, or even government-based set of rules or commissions. Is an AI something that can help us be more compliant or help us deliver those regulations and be more transparent, perhaps? Is it something that you're perhaps using?
Yes, it is. It's actually it was also a surprise for us, and I think maybe we all or you all would find it useful too. It's just a simple idea. Whenever, for example, we need to achieve a compliance with a set of rules, this usually is a pretty thick document that states hundreds, if not thousands, of various requirements, easy and hard to achieve. And
it's something that legal loves, but engineering hates.
Yes, we as engineers, we hate this. It causes lots of trouble for us. However, for us, the solution is Gen AI, because what and we've applied that several times already. So our experience is that we just take the certain class of requirements that usually are pretty obscure for us or vague, or we don't understand what they mean. It requires usually some expertise to understand that. So we don't have it, and we don't have time. So what we do usually, we just put this to the Gen AI model, and the Gen AI model that also knows our code base. And we ask the Gen AI model to create automated test cases as much as possible. And in many cases, actually can use the AI to analyze our code base and provide a set of automated test cases that software can be validated against. So then we can run our software and we can check if these tests pass or fail. Similar situation is when we, for example, medical device regulation (MDR). It's a pretty complex document, and fulfilling all the requirements there is not easy. It's pretty difficult. There are also other regulations around it, like ISO 13485, which is quality in medical device development. So all these norms and requirements and legal documents define additional features that the software must have, and also they define additional processes that the software development lifecycle must have. Like, for example, test coverage. And this is one of the things that we did pretty recently. We just took the existing code base and asked LLMs as Gen AI to create automated test cases that comprehensively test the software. We know that the software works because it's in production. Our test coverage is pretty typical. In some parts there is almost 100% of automated test coverage. Some parts of the system are on the lower figures. We want to have almost 100% everywhere, because that enables us to deliver software that is MDR compliant as a registered medical device much faster, because our quality department has pretty strong opinions about when the software is ready to go to production. usually in the past, it was a common practice to have a release once per year, or maybe twice or 3 times a year. We aim to have a release every week, something that is typical for cloud software as a service businesses, but is very unusual for example, for Medtech. And to achieve these two seemingly contradictive requirements, enters the AI, which will help us to, thanks to its ability to create test cases that cover 100 or almost 100% of our features. Then we can think about faster release cycles while still maintaining the MDR compliance. So yes.
Okay, so you help help back your business with AI services in terms of security, back your business in terms of compliance with AI as well. Wouldn't you? What is your point of view of the sheer threat or security in terms of AI components? Is because they are a solution, a very, very big solution, and an impactful one to lots of problems, but they also cause problems as well. And it seems like there is only a small group of people that understands that very, very well. It's still a new curve. It's still something that that's being adapted, that develops quickly. Each year we have new set of models, new set of tools, new set of approaches, and so on. What's the security there with this? So maybe it's not that the grass is not that green here. What do you think?
Let me unpack this. You mentioned super important thing. What I really see is that first of all, there's lots of misconceptions. The AI models are, for example, the foundational models, the LLMs that are the basis of the Gen AI revolution. These models are either something that we can download and install on our own infrastructure, just the way we did with other software components for years. There's tons of models that are sufficiently small to run on even modest laptops. As surprising as it is, we've reached a point where many AI models are actually too powerful for a task that we want to give them. With proper prompt engineering, retrieval augmented generation techniques and architectures, and a little knowledge about data science like vector databases, or re-ranking, all these things, if you consider creating a solution that is not just built with one LLM, one prompt, but uses the model as a one of the infrastructural components that does a job that it's well tailored for it, then suddenly it becomes clear that you may use much smaller or distilled models that can fit almost anywhere. And this is how we can actually avoid the discussions about running the models in the cloud, which requires providing the data to the cloud operator we might not be comfortable with. That's one thing. But if we need to, what I recommend is to define problem better, ensure that we have proper architecture, that we don't rely only on magical capability of the AI model. And that's why I said that at the very beginning, that the proper engineering thinking or problem-solving approach that we've been doing for years as engineers, as a discipline, we should apply it as well. Because it happens very often that the problem you try to solve can be solved in 90% using traditional software engineering, and just the 10%, the cream on top of it, it's just the AI model that does the marvelous thing. So I would say that this is how we can structure it. Second thing is that if we use a vendor like cloud vendor, some vendors have better reputation, some have worse reputation. We tend to use the best vendors, only those who specialize in infrastructure, and infrastructure is their core business. We don't rely on vendors whose business is not clear to us, so to speak, because we don't know what happens to the data. That's true. Basically, we don't have to use them. Let's stick with the vendors that specialize in infrastructure, and infrastructure is their business, because it would be against their best interest to harm us, because we are the people who build our systems with their infrastructure. So that's kind of natural, I would say. That would naturally eliminate the players who are dishonest with our data. I don't see much issues here, to be honest. There's tons of misconceptions in the public. People tend to overreact to.
I think the only issue is right now is something similar that we experienced like 15 years ago when the cloud-based solutions were being more and more adapted. So basically, a maturity. That those services are not that mature, at least not everyone of them, and we still have to maintain the mentioned sanity. But you mentioned relying on the vendor and trusting the vendors. We have actually three big players here.
Yeah.
So it's Amazon, it's Google, and it's Microsoft. And there's this, in my opinion, in my personal opinion, not that negative, but very often it's considered a disadvantage. At the phrase called vendor lock-in. What's your view on that? I'll start with sharing my own personal opinion, because to me, for sheer amount of businesses that are not that don't operate on that much big of the scale, that are small companies, there are not maybe large companies or medium-sized companies, relying on one vendor is sometimes an advantage, because you maintain one relation with your account manager, with your vendor, with these people, the support. Previously we talked about talent, and you have talent that knows these solutions, that you can help them learn those solutions more proper. And what's your view on that, on the vendor lock-in? Is it something that should scare us, or is it something that we should, I don't know, when we start a business, we should have in mind, or is it something that we can deal with when it's time to deal with?
I would reiterate one more time that we are engineers. An engineer, but I hope you agree with me that an engineer by profession is a person that does things, solves problems using various tools. So we take the tools, and our first job is to find the best or the proper tool for a given problem. We don't theorize about things, we just do things. We are doers. Of course, we need to be thinkers, but most of all, that's our first competence. We are doers. So we do things. And when you want to do something, you need to usually make certain decisions. And to make an engineering decision, we usually weigh in advantages, disadvantages, costs, risks, benefits, time to market, problems with maintenance costs, maintenance issues, and so on and so on. So that's why I would say that what I really see is that when people don't manage their relation with a cloud vendor, then yes, they would have a problem. If you properly manage your relation with a cloud vendor, and what I mean by that, the managing relation means constantly analyzing if your costs are okay, if still the benefits outweigh disadvantages, if you still are happy with the potential exit plan. If you're happy with the compliance and your compliance with the regulations in that using that cloud vendor, we need to constantly adopt this. For example, as you grow, the costs of cloud would naturally go up as well. However, usually people relate the cloud costs with just infrastructure purchase costs, the CapEx cost. But it's not the same, because cloud is also services. Things, we buy infrastructure, but also we buy services that maintain that infrastructure, and we buy certain services that are built on top of that infrastructure. So cloud is not only infrastructure as a service, it's also a platform as a service. And suddenly when you take this into account, you see that your costs to achieve that kind of platform service, like for example, managed database, right? Something that does tons of things besides being just a SQL database. Replication, data replicas, failover, switchover, monitoring, backups, snapshots, just-in-time recovery, you name it. There's tons of features that normally would take at least a full-time engineer to develop and then to maintain. If you need to maintain 24/7, then you need 4 engineers just to fill your shifts. And suddenly, when we take this into account, you see that it's not a vendor lock-in, it's a vendor trust. It's more like we trust that the vendor does this for us. Infrastructure and talent always cost. Somebody has to pay that cost anyway. To that sense, for me, cloud is just enabler, because we can start ambitious project. We can start small. We don't pay much for the infrastructure, just hundreds of dollars to start with, or even less than that. We can prove our concept, we can grow. And for many, many months of growth, there will be no doubts that the cloud is the best option in terms of balance of what we get, costs of exit, potential exit if we want to exit at some point. And so the takeaway costs will be high, will be also that complex. But certainly other factors come into play. Maintaining uptime, maintaining access to the multiple regions, ensuring that the regions are located geographically in preferred places to achieve.
Yeah, at some point, not even the features are a problem. The infrastructure itself is maybe not a problem, but it's a thing that you still need to maintain. You need to improve. You need to refactor, redesign, and basically act how you act on the business needs. At some point you have engineering needs that you need to fulfill. And I'm not talking about talent. I'm talking about the sheer amount of the code of the components of the system, and it's also something that this is a challenge at some point, right?
Yes, it is. But as I said, we are engineers, and we are used to managing complex engineering technical systems. Cloud for us is enabler, is a tool that we use, that we suddenly have, and it's up to us if we make it kind of our advantage, or if we will be struggling with that. Every project is different, as we know it. Every project has got different requirements, business requirements, technical requirements, scalability requirements, uptime requirements, and we always need to weigh the advantages, disadvantages, benefits, costs. It's like with any other tool out there.
That's true. I have one final question on a more macro level.
Mm-hmm.
So nowadays, the mentioned vendors, all of them, Microsoft, Google, and Amazon, all of them are founded in United States. So do we in Europe need to, have in mind that we are sort of building the businesses using the infrastructure that originates in another country? Is it something that we need to worry maybe about, or is it something that we just need to accept because that's how it's designed?
As I said at the beginning, the world is changing very fast. The dominance of US-based big tech companies is obvious. We all see this. Their ability to attract talent, their ability to finance new interesting or projects is beyond our capability right now. However, I always have big trust in Europe. Europe used to dominate the world trade not that far ago. Europe used to dominate technology, was the world power not that long ago. So we have everything we need. We have talent. We have largest single unified market in the world. We have one of the best universities in the world. We are able to attract scientists, and we have everything to become number one again, or be on equal par with US or China. I think we all need this. I don't think that the current landscape of geopolitics is an issue, to be honest, for our cooperation with the American big tech. We see that there are initiatives like sovereign clouds that the projects are already in place and all major cloud vendors are preparing the sovereign clouds. So there will be the clouds that are more compliant with European laws, that are managed from European soil, have separate infrastructure, separate control planes that will be controlled fully by European entities, which is I think enough for us going forward. I also believe that businesses are done by people, and these American companies also they rely on European people, European engineers as well, and we see this every day when we talk to our colleagues from these companies. Every day, they're also from here. Their jobs, their KPIs they need to meet are strictly connected to their success here in Europe with European companies and according to our European rules of the game. So I wouldn't be much concerned about it. There's still a lot to be done. I'm super happy to see that Europe actually started to build their own infrastructure based, for example, on telecom companies. We started to build things that are obvious to build. We just basically, I think, woke up a little bit. So it's very exciting to see this happening, because I think that we can bring, engineers like us who've been working with cloud systems. We have all the expertise, all the experience, all the knowledge that's needed to build similar systems here in Europe if we ever need them.
That's true. That's true mainly because of the talent you mentioned again. We learned those things, and we don't have to be shy skill-wise because lots of big businesses originated in Europe, and those are also big tech companies as well. Thank you, Michał, for this very engaging conversation. We have one question. So let me read that. What specific security challenges do you see in Mediatech industry, and what modern approaches, including AI, help to address them? I think we actually talked a little about that. We can use AI to first of all create monitoring systems to monitor incidents, monitor various components of the infrastructure itself.
I think that in Mediatech there's also an issue because Mediatech and Medtech systems are totally different kind of systems, because Medtech systems are mostly targeted at professionals, and Mediatech systems, at least these ones that we do, are more targeted at the general public. And in these publicly facing systems for customers, for individual customers, for general public, the big issue is fake content. The big issue is so-called user-generated content.
Yeah, that's true.
And almost every business idea that we discuss with our customers, our clients in Mediatech space, we spend a great deal of time discussing how to prevent fake content, how to prevent abuse, misuse, because this is also a security challenge. It can cause financial responsibility of our client. It can bring harm.
It can be a compliance issue.
Actually. There is a compliance issue with that. So AI would definitely help moderate the content. That's my take on this. Another challenge is, and it will become more prevalent. We don't see it now very often, and we see this in research papers. We see this in engineering experiments. However, I think it's not that big issue for general public. Is try to abuse the AI-based or Gen AI-based functionalities, because every Gen AI model is just a general predictive model. It can generate any content depending on the prompt. So, well, we don't see that often it's not a big problem yet, as I said. Maybe because the adoption of Gen AI-based solutions is relatively slow, I think. Despite the hype, it's still relatively slow, especially in terms of publicly faced systems to be used by just anybody. But AI models can get abused. So if we got an AI-based functionality that is supposed to, for example, I don't know, help people going through some kind of support service desk, and suddenly people try to overcome it and the protections and try to use that AI model to generate harmful content. This is a challenge. This is a challenge because people are super creative, and so currently they are able to overcome most guardrails that AI solution vendors put in place to prevent these things from happening. So what we are doing right now is our cloud vendors offer us guardrails as a feature that is tailored to prevent abuse of Gen AI models. And we also usually provide our own models that double check. And this is a kind of adversarial model where two models are trying to keep each other in check to make sure that the models can't be abused. For one reason is that it could be a compliance issue. The second reason is that it could also cause additional costs of processing. So we try to avoid that.
Thank you again, Michał. Thank you, everyone, for joining us. And for my last statement, I would like to invite you to free consultation. In case you need diagnosis or technological advice, feel free to reach us, and we'll try to be of help. Thank you, Michał.
Thank you, everyone. Thank you, everybody.